Hello everyone, in this video I'm going to discuss about the Terraform import command. So the importance of Terraform import. Let's take a scenario to understand it. Let's say you have an organization that has been managing its cloud infrastructure manually. Recently your company has decided to adopt Terraform for better management and automation of infrastructure. You have existing resources such as virtual network, a subnet, a virtual machine, and public IP in Azure, and you want to start managing these resources using Terraform. So, what is the exact scenario? I would say this is an organization name called as ABC, are using Azure, and they have deployed n number of resources inside the Azure. To implement the IAC, they have finally selected Terraform. As I do have mentioned, they do have n resources present inside the Azure. So how they are going to manage the existing resource which has been created manually from Terraform part. So we are good to use Terraform import command to bring manually created resource under Terraform's management without needing to recreate them. So in Terraform, we do have one functionality of import which can help us to manage all the existing resources which are created manually using Terraform import command. And in this command, we do not need to recreate the resource. What is the exact meaning of recreate? Recreate means we don't need to delete these resources and then again we need to create with Terraform. This approach is not required. Directly, we are good to create the state file of all these resources using Terraform import command. So, older approach. In older approach, Terraform import would create the state file associated with the resources running in your environment. The steps are we have to write the resource block. I would say I want to import one resource group. Okay. So for this resource group, I have to write a resource block inside my .terraform file. Okay. This is one of the requirement. Then we need to run Terraform in it. Finally, we need to run Terraform import command to create a state file. The first thing which we need to do, we need to write a resource block for all our resources. The second thing which we need to do, we need to run Terraform init command. And the third thing which we have to do, we have to run Terraform import command. The syntax is we have to write Terraform, then import the resource global name, then the local name, and finally the resource ID. So this is the older approach we need to follow for Terraform import configuration. Terraform 1.5 introduces automatic code generation for imported resources. This helps to reduce the amount of time you need to spend writing your code to match the imported. In this approach, Terraform import can automatically create the Terraform configuration file for the resources you want to import. So in the older approach, the first thing which we need to do, we need to write the resource block. Okay, I would say for around 10 resources, if you want to create a state file, you have to write the resource block for it. The second thing which you have to mention, it is our Terraform init command. Okay, and the third thing which you have to run Terraform import command with a resource block name, global name and local name, and finally the resource ID. But in the newer approach, what we have to do, we have to only run this command apart from the provider configuration. If you see, if I want to import the resource group, I have to mention the global name, which is Azure RM underscore resource underscore group, then the local name, and finally, we need to mention the ID. This line, it is all about the provider configuration. We do not need to write any resource block in our newer approach. The below commands we need to run. The first command, it is Terraform init. As we do have mentioned, it is generally required for the provider configuration. Second command which we need to run, Terraform plan hyphen generate hyphen config hyphen out is equal to file name where we want to save our resource block configuration detail. Okay, so whenever we are going to run this command, it will create a .tf file with a name called demo.tf, and inside the demo.tf, it will have all the details regarding the resource block. If you see here, after running this Terraform plan, it has automatically created the resource block. In resource block, whatever the local name we have mentioned into, it has created inside my .rg .tf file, and it has automatically updated location, managed by name and tags value. Okay, and once we are going to run Terraform apply -auto -approve, it is going to create my state. So the main advantage we are having after one Terraform 1.5 version, we only need to write this two line of code to import any resource, whatever the resource global name it is, and then the resource ID. And when we are going to run Terraform plan, automatically a TF file will be created and the resource block will be updated. And when we are going to run Terraform apply -auto -approve, a state file will be created for us. Okay. So in the next video, we are going to do a detailed demo to understand these things in detail. So thanks a lot for watching the video. Hello everyone, in this video I'm going to do a demo on Terraform import command. So firstly we are going to discuss about the old approach, and then in the next video I'm going to discuss about the newer approach. Okay, so the first thing which we need to create is our storage account, and this storage account will be created by using manual approach. And once this storage account is created, I'm going to write a resource block for it. Okay, and once this resource block is written, the third thing which I'm going to do, I'm going to run Terraform init command. And fourth, I'm going to run Terraform import. Okay, so let's start the demo. Create a storage account. Mention the resource group name as Terraform hyphen import hyphen demo hyphen rg. Then I'm going to mention tf import strg. And the location I'm going to mention here, South India. I'll mention here LRS only. It is for demo purpose. We don't need to change anything. So the storage account deployment in progress. So what is our next step? The next thing which we have to do to create a resource block. So I'm going to search for a storage account, and then I'm going to select the Azure RM underscore storage underscore account, and will copy this configuration. And here I have already created a dedicated folder name called as old underscore approach. Here I will mention main.tf, and will paste the configuration, and our storage account has been created. So let me copy the resource group name and the location which I have mentioned, South India, and our storage account name is tf import storage, and we have account replication type LRS, and we haven't updated anything with tag, so let me remove it. Okay, so we are done with the step 2. The step which we need to do is Terraform init. Let me copy the path. I'm going to type Terraform init. So Terraform init completed. And the final step is Terraform import command. So for Terraform import command, as I do have mentioned, we need to copy the resource ID. But in Terraform import command is not as usual as our Terraform plan. So in each and every documentation, if you scroll to the bottom, you will see one options of import. A storage account can be imported using resource ID. So let me copy it, and I'm going to paste it here. and then I'm going to copy the resource ID. Okay. So if you want to import any resource, what we have to do, we have to go to the Terraform documentation, and at the bottom you will get a command for it. It is Terraform import, whatever the global name it is, and then the local name. Okay. And this is the resource ID. Here our local name is example, so I'm going to update it here, and then I'll remove it. If you see, we are having our main.tf, which we have created for our resource group and storage account import part. Then after running Terraform init, we are having our .terraform folder and .terraform log.scl. So here I'm going to run this command, and let's see, is it the state file is created or not. So I'm going to run Terraform import command. See, we got a message, import successful. The resource that were imported are shown above. These resources are now in your Terraform state and will henceforth be managed by Terraform. If you see here, finally our state file has been created, and this state file has a detailed information about both the resources, our resource group and our storage account. Okay, so in the next video I'm going to do a demo on our newer approach. Okay, so thanks a lot for watching the video. Everyone, in this video we are going to discuss about the newer approach of Terraform import command, which is applicable after Terraform 1.5 version. Okay, so we have already created a storage account, so it is not required. The second step we have done, writing the resource block. This step is not required in the new approach. In the new approach, we are good to run Terraform init, and then in terms of import, this part is also not applicable. We need to run Terraform plan, and this Terraform plan will create the resource block for us. And then finally, the Terraform apply. Okay, so let's start our demo. So I'm going to mention a file name called as main.tf, and in main.tf, what we have to mention, we have to mention import. So what is my resource name? It is Azure rm underscore storage underscore account. I would mention example here. Okay, and then what is the id? Id of this storage account is, okay, and finally one block for our provider configuration. Copy the path, mention cd. In the first command we need to run Terraform init for the initialization purpose. The next command which we need to run, so in the newer approach we have to mention Terraform, then plan, and hyphen generate, then hyphen config, hyphen out is equal to the place where I want my resource block Terraform file. So I'll copy this path and I'll paste it. And what would be my file name? I'll mention here as demo dot, or I would say storage.tf. If you see here, we are currently having main.tf and providers.tf and .terraform and .terraform log.scl. We are not having any file which contains information about the resource block. Okay, let me press enter. If you see here, we are getting an error. So what is the error? Failed to create target generated file. The system cannot find the mentioned path. Okay, what is the exact issue? I have copied the path, and in the path, what is the mistake I have done? I have mentioned here providers.tf. Okay, the providers.tf should not be there. It should be inside the new approach. So let me update the path and rerun this code again. See, it is saying 1 to import, 0 to add, 0 to change, and 0 to destroy. And it has created a storage.tf, and this storage.tf is generated by Terraform. Please review this resource and move them item into your main configuration file. And it is clearly mentioned generated by Terraform from whatever the resource ID we have mentioned. And it has a detailed information about each and every attributes of our storage account. So when we initiated the Terraform plan command, what it has done, it has created a resource block. But in the older approach, we used to create this resource block and it was really tedious task to do it. Okay. So let me run the Terraform apply. To save the time, I mentioned auto hyphen approve. Resources 1 imported, 0 added, 0 changed, 0 destroyed. If you see, finally we are having our state file, and this state file we have created by using the newer approach. If you compare with the older approach and the newer approach is more simplified. Here we do not need to write a resource block. We only need to use the import block, and within an import block we only need to mention the resource global name and the local name and the resource underscore id. Okay. And in terms of running a command, we do not need to run, I would say, Terraform import command, which I have showed you in official documentation with the unique ID. What we have to run, we have to run Terraform plan command with the hyphen generate hyphen config and with a path where we want to create our Terraform configuration, and then finally the Terraform apply. Terraform plan command will create a TF file which has all the resource block present, while in the case of the Terraform apply, it is going to create our state file. Okay. So with this, we have completed the import functionality. So thanks a lot for watching the video. Thank you. Hi everyone. In this video, I'm going to discuss about the Terraform provisioners. End-to-end infrastructure deployment with Terraform. Till now, we have been working only on creation and destruction of infrastructure scenario. So what is the exact meaning of it? So from the day one, what we have discussed is creating the resources. Okay. And the second thing which we do have discussed, like deleting the resources. So these are the two things which we do have discussed till now. Let's take an example. We want to create a virtual machine and installed web server in it with Terraform. What is the exact problem? It is only a virtual machine. It does not have any software installed. What if we want to complete end-to-end solution? So in the last video, we discussed about the creation of virtual machine. After the creation of virtual machine, we want to install some set of software, I would say web server. Configuration management part, how we are going to achieve it. So understanding the provisioners. Provisioners are used to execute scripts on a local or remote machine as a part of resource creation or destruction. Let's take an example. On creation of instance, execute a script which install Nginx web server. The same thing which we do have discussed in the last video, like creation of the virtual machine and then installing some set of software into it. Terraform has capability to turn provisioners both at the time of creation as well as destruction. So in this video, we are going to discuss only about the creation process. In the upcoming videos, we'll discuss about the destruction process. Basically, there are three main type of provisioners: local exec provisioners, remote exec provisioners, and the file provisioners. Local exec provisioners. Local exec provisioners allow us to invoke local executable after resource is created. What is the use case? After the VM is created, this provisioner run a command to write the virtual machine public IP address to a file name called myip.txt. So what is the first thing we are going to mention here? The provisioner, then the type of provisioners, and then here we need to pass the command. Here we are passing the global name of Azure RM underscore public underscore IP dot local name, and what we want a IP address. So once we are going to run the Terraform plan and apply, it is going to create a file name called as myip.txt, and in this myip.txt will have our public IP configuration. So this is the basic functionality of local exec provisioners. Once the virtual machine is going to be created, it is going to fetch the data of the public IP and going to store inside the file name, I would say myip.txt. And this myip.txt will be stored in our local machine. Remote exec provisioners allow us to invoke scripts directly on the remote server. It is useful for tasks that need to be executed after the server is created. Let's take example. Once you create a virtual machine, you want to install Nginx and start the Nginx server. So this is the first thing which we do have discussed in the slide 1. Like we have created a virtual machine, and once this virtual machine has been created, we want to install some set of software. To achieve this part, we are going to use remote exec provisioners. And this is also called configuration management things. Like once the infrastructure created, what we are doing, we are creating the configuration for it. So what would be the first step? The first step, it would be like provisioners we have to mention, then the type of provisioners, it is remote-exec. So the whole process is divided into two steps. The first one is regarding the connection and second one is regarding the inline command. So in connection is basically responsible after the virtual machine is created, it is going to connect with my virtual machine. To achieve this thing, it is going to use SSH because we are using Linux virtual machine in this example. While in the case of Windows, we need to mention Windows 1. User, password and host. So user will consist of the admin underscore username, password will consist the admin underscore password, and the host, it would be the public IP address. And self is a keyword which is used to mention to fetch the values from the current Terraform configuration. So wherever it is mentioned admin underscore username, the value will come. Why? Because we do have mentioned self keyword. The second part, it is inline. Here, the first command, it is going to update our operating system. Once it is updated, it is going to install Nginx on it. And after the Nginx installation, it is going to start the Nginx service. Okay. The third provisioner is file provisioners. File provisioners is a tool used to copy files or directories from the local machine to a remote server. Let's take an example. Once you create a virtual machine, you want to copy the files. So we do have created virtual machine. We do not need to do any kind of configuration changes in terms of like installing some set of software. Instead, what we want, we do have some set of files which we want to copy it from our local machine to the remote machine, which is eventually our virtual machine. So for this one, we do have the file provisioners. So it consists of the two things. Again, the first part, it is regarding our connection. So it is a Linux machine. So that's why it is mentioned SSH. And then again, the username, password, and the host. And the self is a keyword which is going to fetch the value for admin username, again for password and the public IP address. And the second thing, it would be like the source and the destination. Source part to the local script file. So this is the script file which need to be copied from my local machine. While destination /tmp /script.sh. So in this location in my virtual machine, this file will be copied. Okay. So in the upcoming video, I'm going to give a demo on all these provisioners like local provisioners, remote provisioners, and file provisioners. Hi everyone, in this video I'm going to do a quick demo on local exec provisioner. So what I have done till now, I have created a file name called as providers.tf to save our provider configuration, and then we are having our main.tf. So in the main.tf, what we are going to do, we are going to create one resource group named as Kumar RG underscore local underscore demo. And in this one, we are going to have our virtual network then subnet, and then we are going to have our public IP, and then network interface card, and finally we are going to have our Azure RM Linux virtual machine configuration. Okay, so once this virtual machine has been created, what to do the next step? It is going to call this local exec provisioners, and in this local exec provisioner, it is going to call this value name called as Azure RM underscore public underscore IP dot example dot IP address, and whatever the value, I would say the public IP, it is going to save inside the myip.txt, and the location of myip.txt, it would be in our local machine. Okay, so let me firstly copy the path and implement the changes. So the first command I'm going to run called as Terraform init. Just to save the time, I'm directly going to run Terraform apply hyphen auto hyphen approve. So it is going to create the 6 resources: our virtual network, subnet, resource group, public IP, and NICard, and our Linux virtual machine. So the resource group creation process is started. Created, and once my virtual machine created, then my local exec part is started. So in local exec, what we do have mentioned, it is going to save this public IP in the file name called myip.txt. And if you see here, we do have our file name called as myip.txt, and let me myip, and here we are able to see our public IP. And if you're going to just, if you're going to do a quick comparison from portal, let me refresh it, and let me click on this public IP, and this is the address which we are having: 20.235.113.132. And if you see here, we are having the same IP. What we have done, so firstly, our virtual machine has been created, and once this virtual machine created, it has executed local exec provisioners, and in the local exec provisioners, it has fetched the public IP, and then it has been saved inside myip.txt. So this is the main functionality of local exec provisioners. It will save the data inside our local machine. Hi everyone, in this video we are going to do a demo on remote exec provisioner. So I have created a two file. First is called providers.tf, where we do have provider configuration, and the second one is main.tf. So in the main.tf, we are having n number of resource block. So what is the main purpose of this remote exec provisioners? Once this virtual machine is created, what we have to do, we need to add some set of software, or I would say in general the configuration part. Okay, so this resource block is responsible for creating the RG, then our virtual network, then subnet, public IP, NIC, and the last one is for our Linux virtual machine. If you see inside this Azure RM Linux virtual machine, what we do have mentioned, we have mentioned remote exec provisioners, and for the connection part, we have mentioned the type SSH because it is a Linux virtual machine, and username, password, and host. And we have mentioned the self keyword because it is going to find the admin username, password, and public IP address within this Terraform file configuration only. Okay. Once our virtual machine is created, it is going to make this connections, and after the connection created, the second thing it would be running this set of commands. The first thing it would be update our operating system, then install the Nginx, and the third one is to start the Nginx server. Okay, let me quickly run the Terraform init and apply to initiate the implementation. I've typed a command Terraform init. There's one typo. I'm going to run command called Terraform apply hyphen auto hyphen approve to save the time. So 6 of the resources are going to be created, which includes our virtual network, subnet, resource group, public IP, NIC card, and our Linux virtual machine configuration. If you see here, I would say the 6 resources created, and parallelly what we are having, the remote exec part also completed. So what does it mean? Firstly, the virtual machine created. When I'm mentioning virtual machine, it would include all the component. I would say the resource group, the virtual network, the subnet, the NIC card, the public IP, and the Linux virtual machine configuration. And once this part is completed, the second phase is all about the configuration part, or I would say the remote exec provisioner part. Then the first thing it would be in connection, and the second one it would be our running all this command. Let me show you inside the CMD. If you see here, the first thing which has been completed, our virtual machine creation part, and then our the connection happened. So the first thing it is connecting to remote host via SSH, and the first thing it is the use IP address, the username, and the password. Okay, and we have disabled this certificate, the private key configuration. That's why it is showing false. Once this connection part completed, it is showing connected. Then the next stage is all about running all this command. So throughout this step, whatever the things you are able to see on terminal, it is regarding the implementation of this inline command. The first, the update of the software, then installation, and then starting it. So what I'm going to do, I'm going to log in inside this virtual machine, and then I will check whether this software has been installed or not. So the public IP is this one. I will just click on putty, open. The username is admin user. I'm good to mention it. And here we do have mentioned the password configuration. Okay, so it has been connected to the Linux virtual machine. I'm going to run a command called system ctl status nginx and see the nginx service in active stage. So what does it means? It means that once this virtual machine was created, then the connection happened, and once it is connected, the third thing happened. It is regarding the installation of our nginx. Once this nginx was installed, it has been active. So this is a perfect example of remote exec provisioners where we have created our virtual machine and we have done some configuration changes. Hi everyone, in this video I'm going to do a quick demo on file provisioner. So what is the main functionality of the file provisioners? Once this virtual machine is created, we need to copy the file from our local machine to again the virtual machine. So this is the configuration which we need to follow for the file provisioner. The first thing again, it would be the connection which we need to establish between our local machine to virtual machine, and the second thing it would be we need to mention the source and the destination. So in this demo I have created a three file. The first file, it is all about the main.tf. In main.tf, again the same thing I'm doing. We are going to create the 6 resources which includes all the configuration like our resource group, virtual network, subnet, public IP, NIC card, and our Linux virtual machine configuration. And in providers.tf, I have mentioned regarding the provider configuration, and script.sh, it is a file which is going to be copied from our local machine to the remote virtual machine. Uh, As we do have discussed in remote provisioner, the first thing which we need to do is regarding the connection, and the type of connection, it depends upon what kind of operating system we are using, and the three things required: the username, password, and the host, which means the public IP. And self is a keyword which we need to mention to fetch the values from the Terraform configuration. Okay, let me quickly run the Terraform init. I'm going to run a command called Terraform apply -auto -approve to save the time. Our resource has been created, and if you see here, once the resource created, our provisioner part initiated. So let me quickly see inside here. The virtual machine creation process is started, it has been completed, then provisioning with file, and then the creation complete after 49 seconds. So it means whatever the file content we are having like script.sh, it has been copied to this path. Let me quickly log in inside this virtual machine and cross check it. So we do have this public IP. I'm going to copy it, mention in putty, then our username, password part. Okay, and directly I'm going to cd on this specific path. And if you see here, we are having a file name called as script.sh. Let me script.sh. And here we are having and the content of the file is this is a demo for file provisioners. Okay, and if you see here also, it is the same thing. So this is the perfect example of file provisioners where we have created our virtual machine, and once the virtual machine is created, copied the file from our local machine to virtual machine. The first thing is regarding the connection, and the second thing is like copy the file from the source to destination. Okay. Hi everyone, in this video we are going to discuss about the Terraform Taint. Overview of Taint. You have created a new resource via Terraform. Let's take an example. You have created a virtual machine and user have made a lot of manual changes both infrastructure and inside the server. So from portal I would say they have done n number of changes in virtual machine in terms of its configurations and also from the part of NSG and the other rules. Two ways to deal with this: import the changes to Terraform and delete and recreate the resource. To import the changes into Terraform, we are going to discuss in our upcoming videos. Delete and create the resources. This one we are going to discuss in this video. Taint. So what is the exact meaning of taint? The Terraform taint command manually marks a Terraform managed resource as tainted, forcing it to be destroyed and recreated on the next apply. Let's take example. We have created one resource group, then our VNet, then our I would say subnet, then the NIC card, then the public IP, and finally our virtual machine. Okay. So out of this six resources, user have made n number of changes from virtual machine. I would say through manual approach. We want to undo it. So what are the options we do have? So in the last slide, we discussed about the import option, which we are going to discuss in our upcoming videos. And the second option, which we do have called Taint. So Taint will do what? Taint will firstly delete the resources and create the resources. So how to taint the resource? The, to taint a resource, the command is terraform taint resource type dot local name. So the command it would be for our virtual machine terraform taint azure rm underscore linux underscore virtual machine dot demo underscore virtual machine. This command will not modify infrastructure, but it does modify the state file in order to make the resource as tainted. So once this command is initiated, it is going to update my state file and will change the status of this resource to be as tainted. And once a resource is marked as tainted, the next plan we have tainted this resource, and next time when we are going to run terraform plan, it will show the two things. One, it would be delete, and the another one is to create the resources. And the third time when we are going to apply, it will delete the resource and create it. So in the next video we are going to do a demo on. Hello everyone, in this video I'm going to do a quick demo on Terraform Taint. So what I have created till now, I have created a file name called as providers.tf, which do have provider configuration, and then I am having main.tf. In the main.tf, the same thing I'm going to do, like to create a virtual machine, and then parallelly I'm creating the virtual network, subnet, public IP, NIC, and the Linux virtual machine. Okay, let me copy the path and run the command for it. So the next thing I'm going to do to run Terraform apply -auto -approve. So once all these 6 resources created, what would be my next step? I'm going to implement the tent command. So for the tent implementation, we already discussed in detail. Like the first thing which I have to do, I have to tent the resource. Okay, and once the resource is tented, if I'm going to run Terraform plan, what it is going to show? It is will firstly show to destroy the virtual machine and then create the virtual machine. Okay. And one more thing, once the resource is marked as tainted, what would happen? It is not going to do anything. Our state file will be updated. In the state file, the status of this resource, it would be as tainted one only. Okay. So let me firstly create the resource, and once the resource is created, we'll follow these steps. If you see here, our all the 6 resource has been created. So what would be the next step? I'm going to mark the resource as tainted. So to mark the resource, any resource tainted, the first command I have to run terraform taint, then the global name of the resource dot, what is the local name of this resource is example. So I'm going to type here as example and see the resource Azure RM Linux underscore virtual underscore machine has been marked as tainted. So the first step has been done. Let me quickly check inside our state file. What is the status of this one? It is showing as tainted. Let me maximize it. If you see the Azure RM Linux virtual machine status is tainted. If you see, let me run Terraform plan and see what it is showing to us. If you see here what it is showing to us, one of the resource it would be add and one of the resource will be destroyed. So firstly it is going to destroy the resource whatever the virtual machine configuration we do have, and then second it is going to add this resource. Okay, and one more thing, if I'm going to untaint the resource, Azure RM Linux virtual machine example has been successfully untainted. If I'm going to run Terraform plan, it is showing your infrastructure matches the configuration. While in terms of Terraform state file also, the status of this is not tainted. Let me quickly taint it again and run Terraform apply. And type yes. See, the firstly it is going to destroy the virtual machine and then the creation process will be started. And if you see here, the resource has been deleted firstly and then it has been created. So this is the basic functionality of the taint command. To achieve the taint, what we have done, the first thing, whatever the resource we want to taint, we have tainted it using a taint command. And once the resource is tainted, the state file will be updated. Okay. And the second run, whenever we are going to run Terraform plan, it will show the resource will be firstly deleted and then it is going to be create again. And if I'm going to run the Terraform apply, the same thing it is going to happen. It will firstly delete the resource and it will create it. Okay, and there is one difference between the Terraform destroy command and Terraform taint command. The difference between the Terraform destroy and the Terraform taint is The destroy command will delete the resources, while Terraform Taint will firstly destroy the resources and then it will create it again. Okay, so hi everyone, in this video we are going to discuss about the provisioners behavior. Okay, so in the last video we had to have very detailed discussion. There are two types of provisioner behavior. One, it is creation time provisioner behavior, and the second one is deletion time provisioner behavior. Okay, so if we are going to create any resource, I would say our virtual machine, and then the provisioners will run. If there is any problem with the provisioner, I would say in terms of typo or the whatever the software we have mentioned, it is not able to install it. So in this case, the resource will be marked as tainted. So what is the exact meaning of taint? If any resource is marked as tainted, in the next plan, it is going to show you it will be deleted and it would be created again. So to overcome this kind of issue, we do have one options in Terraform to mention on failure is equal to continue. So in this case, what it is going to happen, it will not going to give us any error regarding the provisioner. It will skip that part and our resource will not be marked as tainted. So let me quickly do a quick demo to discuss about the creation time provisioner behavior. In the next video, we are going to do a demo on destroy time provisioner behavior. If you see here, I have created a two file name called as providers.tf where we have provider configuration, then main.tf. In main.tf, there is one typo with nginx. We have mentioned one stri. So whenever we are going to initiate this one, we are going to get an error. And due to this error, the whole resource, I would say our Linux virtual machine will be marked as tainted. And in the next run, again, it will ask us to delete the resource and to create it again. Okay, so let me do this part. I have initiated a command called terraform apply hyphen auto hyphen approve. So let's see what we are going to get. If you see here, we are getting an error. Why we are getting this? Because our nginx, it is not able to install it. Okay. If you see from the top, firstly, it has created all the resources, all the 6 resources. And once the resource is created, it has connected to my virtual machine. And then it has initiated the process of updating the operating system. And once the operating system is updated, it will look for this nginx. But due to typo, it is not able to find any software with this name, and finally it is giving us error. So in the last video, what we have discussed, if provisioners is going to fail, so in this case the resource will be marked as tainted. Okay, so let me quickly check inside the state file and see whether the Linux virtual machine is marked as tainted or not. If you see here, this resource is marked as tainted. If I'm going to run again terraform apply hyphen auto hyphen approve, it will give me one resource to create, one to create, and one to destroy. See, we are getting a message one to add, one to destroy because the resource is marked as tainted. So currently we do have the two options. The first option is to rectify whatever the error we do have in this provisional. If we are going to rectify it, then automatically the virtual machine will be created and the remote exec provisioners will be created without any error. The second option which we do have to update here on failure is equal to continue. On underscore failure is equal to continue. So what we have done, we have updated on failure is equal to continue. So in this case, what it is going to happen, if there is any error inside this provisioner, it is not going to mark the resource as tainted. It will ignore whatever the error it is coming. So this is the benefit of on failure is equal to continue. If you see here, we are getting the same thing. Right now we have updated this on failure is equal to continue. Let me run it again. Our Terraform apply hyphen auto hyphen approve. it will ignore the nginx typo. See, we are not getting any error because we have mentioned on failure is equal to continue, and it is not able to find any package with this name. And let me quickly check inside our state file. It is marked as tainted or not. So currently the resource also is not marked as tainted. So this is the basic benefit. If we are going to mention this on underscore failure is equal to continue, it will not mark the resource as tainted. And if there is any error, it will not give us any error to our terminal. So this is the benefit of creation time provisioner. Hi everyone, in this video I'm going to discuss about destroy time provisioner behavior. So by default, if you are going to delete any virtual machine, what it is going to do, it is going to delete it. Okay, but in some cases what we want to firstly execute some command inside the virtual machine, and once this command is going to be completed, then we are good to delete the virtual machine. I would say we want to firstly uninstall the nginx server, and once this nginx has been uninstalled, then we are good to delete the virtual machine. So this, to achieve this part, what we do have the option, we do have destroy time provisioner behavior. So in this case I have created two file name called as providers.tf and main.tf. In providers.tf, I do have the provider configuration, and in main.tf, I do have mentioned this thing, provisioner remote exec, and when is equal to destroy. The first thing, the connection will be initiated, and then this inline command will be initiated. It is going to remove the nginx, and once this nginx is going to be removed, then it is going to delete the virtual machine. Okay, so to achieve this one, what we need to use, we need to use when is equal to destroy. Okay, so let me firstly I'm going to create a virtual machine, and while creation of the virtual machine, the remote exec is going to install some set of software, I would say the nginx. Then in the second stage, what I'm going to do, I'm going to delete this virtual machine. While deleting of the virtual machine, we'll see the first thing, it is going to firstly uninstall this nginx server, then the virtual machine deletion process will be started. So the first command I'm going to run, Terraform init, then Terraform apply hyphen auto hyphen approve. So what it has done, it has created the 6 resource, and once the resources has been created, it has connected it using a remote provisioners, and it has installed this nginx and start the nginx service. So here we do have mentioned when is equal to destroy. So the first thing, again the connection will happen, and the second thing, it will remove the nginx from our virtual machine, and then the deletion of this all these 6 resources will be initiated. So rather than deleting all the resource, what I'm going to do, I'm going to delete only virtual machine. I would say Terraform state list is a command to list all the resources inside our state file. I would say Terraform destroy hyphen target, and we want to destroy Azure RM Linux virtual machine dot example, and press enter. If you see here, it is going to destroy my virtual machine configuration. I will type yes. So the first thing it is doing, it has connected to my virtual machine using SSH, and once the connection has been happened, the second thing it is doing, it has removed the nginx from this virtual machine, and then it has initiated the process of deleting the virtual machine. So this is the benefit of using destroy time provisioner behavior. Whenever we are going to mention when is equal to destroy and set of command, it is going to execute it before deleting our virtual machine. Okay,